Let's do this one more time, but with a system of 3 equations with 3 variables. So let's start out with our matrix. We need a matrix A times a matrix X equals the matrix B. Well, remember that the matrix A is the coefficients. So let's go ahead and write that matrix out for ourselves. That matrix A with the coefficients would start out with the X coefficients, which is -2, 3. Oh, I can't see the last one. Sorry, that was a -3. The last one's a hidden 1. Then you'd go after your Y's. Well, the first one has a 2. Next one has a 4. Last one doesn't have any Y's, so I can put a 0 as a placeholder. Then we've got our Z's, which are 4, 5, and 2. 4, 5, and 2. Then I can do my matrix for my variables. Well, my variables were X, Y, and Z, and in that order. So my matrix X with my variables should be the matrix with just X, Y, and Z in them. Now equals matrix B on the other side should just be my coefficients. So let's take a look at that. That should be 3, 1, and 2. So I should be having that as my last matrix on the other side, 3, 1, and 2. Now what our theorem says is if we want to solve for X, Y, and Z here, we need to take this matrix and move it to the other side by putting the inverse out in front of the other matrix. So what we'll do is we'll leave the X, Y, Z over here, and we will move the inverse in front of my other matrix. And then my constant matrix, the 3, 1, 2, will stay the same. The problem is I need the inverse of my matrix over here. Well, what's the problem with that? The only way to find the inverse of a 3 by 3 matrix is if you do that thing where you put your matrix on one side and the identity matrix on the other side, and you do row operations until the left-hand side turns into the identity matrix, and the right-hand side will automatically, when you're all done, be the inverse. Well, if you want to, I highly recommend you practice on that. If you do that by hand, you'll get the matrix -4/5, -9/5, 2/5, 2/5, 4/5, -1/5, 3/5, 1/5, and 1/5. I would highly recommend that you know how to do this by hand for both the test and the final exam. So this is a good one where you could go check it yourself. Do it by hand. Pause the video and try to do that on your own. Although that is not what this problem is about. This is making sure you understand the concept. Once you do have the inverse, you can plug it in here, and now we can solve our equation and figure out what X, Y, and Z are now equal to. Well, now we're just multiplying 2 matrices, and we should get an X, Y, and Z, so it should just be another 3 by 1 matrix. So how do you multiply matrices? So you start out with first row, first column, and making sure you multiply the -4/5 and the 3, the 2/5 and the 1, the 3/5 and the 2, and then making sure you add up everything. And when you do, you'll get a -4/5. Then you'll go after multiplying the -9/5, 4/5, 1/5 row along with the column. you'll do the negative 9/5 times the 3, then 4/5 times the 1, the 1/5 times the 2. Add up all of that stuff, and that will be your second entry, which should be a negative 3/2 when it's all said and done and reduced. Last one, you'd go after doing your last row in your last column again. So you do your 2/5 times your 3, your negative 1/5 times your 1, and the 1/5 times your 2. Add up all of that, and you get a 7/5. What would all of this mean, though? This would mean at the very end of the day that your x is negative 4/5. It would also mean that your y is equal to negative 3/2, and that your z here is equal to, 7/5. So as a final answer, you can write that your x is equal to negative 4/5. Your y is equal to negative 3/2, and your z would be equal to 7/5. Again, what this has done is given us an entirely different way to solve a system of equations, but this time using the inverse. Again, the idea is that you're taking the inverse of a matrix A on both sides to get rid of the A so you can figure out what does x equal. And the reason why you're doing this is because that's the only way to get rid of a matrix A is with its inverse, because we don't know how to divide matrices. The best we can do is taking its inverse. But again, be sure, if you do the inverse on the left-hand side to get rid of the matrix, you're going to still have to, when you do it on the other side, put the matrix, the inverse matrix on the left-hand side as well. Because again, matrix multiplication is not commutative. You cannot switch them around. They have to stay in the same order.